Hi, I'm Charles Gray. I'm a senior on Team Thrust 1501's first robotics team. This year, I helped develop the shooter on a robot we named Invader. During prototyping, we discovered that our main game strategy required two positions on the field to shoot boulders and at the tower of this year's FRC robotics competition called Stronghold. We wanted to be able to shoot close up and further out from the tower. On the original prototype, we used a screw to adjust the hood, which changed the angle and trajectory when the boulder left our single-wheel turreted shooter. In order to automate this feature, because you can't walk out in the middle of the field and adjust a screw in the middle of the game, we selected PhD's compact CRS series air cylinder. We only needed a half-inch of stroke to divert the hood angle for the two desired positions. The CRS cylinder was controlled via the driver station through some software programming and worked flawlessly for our needs.
Hi, I'm Josef Thompson, and this year I was involved with solving the problem of how to pick up the boulders from the floor and also lower a castle defense called the Shovel de Frise, which kind of looks like a teeter-totter. How's it go, Charles? Throughout the robotics season, we actually had 6 generations of what we call the Tomahawks. Early on, we selected PhD's Optimax OCG series cylinder to move the Tomahawks up and down on the robot. We discovered later that the original half-inch bore cylinder sizes did not supply enough power to quickly manipulate the Shovel de Frise to our liking at only 11.7 pounds of force per cylinder at 60 psi. We eventually swapped out the original cylinders to a larger 3/4 inch bore size, which produced 53.6 pounds of downward force for the pair versus the original 23.4 pounds for the half-inch bore. We are thankful to have PhD as a sponsor that allows us the ability to gain engineering experience by applying air cylinders to our Tomahawk mechanism.
Hi, my name is Jake Garlits, and I've partnered with Charles to prototype how to actually shoot the boulders from our robot's flywheel-type shooter. After we picked the boulder off the ground, we had to cue or hold the boulder in our machine until the driver was ready to launch it at the castle tower. Because our wheel-type shooter required a bit of spin-up time, we needed a way to index the boulder into the spinning wheel. Once again, we looked into the Optimax OCG cylinder, and that connected to a 1 to 4 lever arm that one of our mentors helped us with. That lever kicked the boulder into the shooter, kind of like this. Wait, Charles, how's that go?
Hi, my name is Sharon Sitton. I am the lead electrical sub-team student lead on Team 1501. I helped design and plumb the pneumatic system in our robot Invader. We used 2 types of solenoids on our robot. We used a single solenoid for the shooter index, which when the driver pressed the button on the driver station, the boulder would launch, and when he released the button on the joystick, the index air cylinder would retract. For the adjustment in Tomahawks, we used a double solenoid valve to retain that position and was selected for each device.
Hi, my name is Nash. This is my last year in T1501, and I was the robot driver. Over the past 4 years I've been on the robotics team, I've learned a lot about pneumatics and how to apply them on our robots. This year, we use a new PhD product called Optimax that replaced our old Bimba cylinder standard. We like the OCG cylinders probably because of the off-the-shelf mounting brackets that are optional and the ease of use. With only 6 weeks to design and build a robot, we'd rather purchase mounting hardware than spend valuable time CADing and fabricating mounting brackets for other air cylinders. Thanks to our mentors from PhD and Yamaha Robotics who provided me with an intern position this summer. I'll be attending IPW this fall to study mechanical engineering. The learning experience I've gained has been an invaluable start to my career. Thank you, PhD, for the early pneumatic experience.